Hello students, today we are going to study river model. Now in river models, distorted models are used. A model is said to be distorted if it is not geometrically similar. For distorted models, different scale ratio for horizontal and vertical directions are used. In the case of river models, if undistorted model is used, the depth will become very small and hence there will be difficulty in measurement. Depth becomes so small that flow in model may not remain turbulent as is there in case of original river. However, as the model will not be similar to river, result obtained from distorted model cannot be directly transferred to river prototype. But this type of arrangement gives some approximate understanding of the flow situation, hence it is used. Therefore, LRH will be equals to scale ratio in horizontal direction, which will be equals to length of prototype upon length of model will be equals to width of prototype upon width of model. LRV will be equals to scale ratio in vertical direction, which will be equals to under root of HP upon HM will be equals to under root of LRV, that is the velocity ratio. Now AR will be equals to width of prototype into height of prototype upon width of model into height of model, which will be equals to LRV into LRH, that is the area ratio. Discharge ratio QR will be equals to AR into VR, which will be equals to LRH into LRV into under root of LRV, which will be equals to LRH into LRV to the power 3 by 2. If Manning's equation is used in this case, then V will be equals to 1 by N, R to the power 2 by 3, S to the power 1 by 2. Therefore, R will be equals to A by P, which will be equals to LH into LV upon LH plus 2LV. Now, if LV is neglected being small, therefore R will be equals to LV only. Therefore, VR will be equals to 1 by NR into LRV to the power 2 by 3 into LRV upon LRH to the power 1 by 2. Using Froude law, VR will be equals to under root of LR. That is all about the river model. Thank you very much, students.